We are in Algebra 2. We are on lesson 13-3, properties of exponents. Let's dive right in. All right, so if I have, and this is the key part of today's lesson, you have to have the same base for this trick to work. If you have the same base and the same base and you're multiplying, then what do I do with A and B?
Add them.
Indeed, you add them. So this is going to be x to the power of A plus B. What if instead of multiplying here, I still have the same base, but now I'm dividing them? Someone other than Marley.
Subtract.
You do indeed subtract. This is going to be x to the power of A minus B. There's an extra trick with this one I can show later, but for now, that's a good enough rule. What if I have a power to a power? Someone new. Ooh, good guess. Not divide. Another one, Grace?
Multiply.
You do indeed multiply. Yeah, it's going to be x to the power of A times B. There's actually going to be never a scenario where you're going to divide up here unless you somehow have fractions happening up here, like maybe 3 times 1/2. Then it'll be 3 divided by 2. But typically speaking, we're only multiplying. I don't want to do that to us, so we're going to not do that for this lesson. All right, this is one that a lot of students frequently miss. I have 2 boys that need to participate in the back. Anything to the power of 0 is... Very good, Eli. Yeah, it's 1. A lot of people mistakenly say, the power of 0 means it's 0. Anything to the power of 0 is 1. And this is the question where I love to ask, why? I know, it's a hard question, right?
Yeah, I just pull a big hangout. Oh, look.
Let me give you guys an example on the side that I'll erase in a sec. What if I have 2 to the power of 3? Do we know 2 to the power of 3 by heart? It's a perfect cube that's on my wall. It's 8. Very nice. What about 2 to the power of 2? 4. What's 2 to the power of 1? 2. And let's pretend for a sec we do not know 2 to the power of 0. Well, let's look at the pattern. 8 to 4, I'm dividing by 2. 4 to 2, I'm dividing by 2. 2 to whatever this mystery number is should continue this pattern and divide by 2, and therefore it needs to be 1. So it's an answer that I don't like giving, but the answer to why x to the power of 0 is 1 is because it works, because it continues the pattern that we know with our properties of exponents. And that brings us to another point. What happens if I go even further? What happens if I decide to go to the power of -1? I continue marching down in terms of powers. This is going to be equal to what? Well, we don't know, right? So we just do this pattern. Just divide by 2.
-2?
Good guess. But again, if I'm just doing 1 divided by 2, if I have 1 piece of pizza and I divide it between 2 friends, each friend gets how many pieces of pizza? 0.5 or a half, right? So you can either do decimals or fractions. I prefer fractions. 1 divided by 2 is 1 divided by 2. And how did I get that? What I did is I put that 2 on the bottom and I made this power a positive 1. So the rule here that I'm going to have here is 1 over x. And I'm just going to, I guess there's an invisible hidden power of 1. This switches. So let me make this a more generic rule. Let me make this a power of n, and then I can say that this is x to the power of positive n. And I'm going to make this more generic in this case as well. What if I already have something that's flipped, and I have a negative power? I flip it again, and now it's x is not in the bottom, it's in the top. And it's x to the power of, it's not a negative power anymore. Again, this negative went to a positive, and now this negative is also going to go to a positive. All right. Fist of 5, how are we so far with the first 6 rules that I have here? I'm seeing 5s, a 2 from Eli. Oh, a 4, 3, 3.5, Evan. At a 4, okay. Do you guys have any clarifying questions that I can answer to have a better understanding about properties of exponents? Once we see some examples, it'll definitely make things more concrete.
X negative, you can just flip that to the top to make it positive.
Exactly. This goes to the top. You don't flip the entire fraction, really. You just bring the thing that has the negative power to the other side. You take this thing that has a negative power to the other side of the invisible divided by 1. And that's going to trick us here in a little bit once we do some example problems. These aren't really rules, but they're things that you'll see, so I want to talk about them. If I have 2 different bases in the bottom that are being multiplied, again, if there's a plus sign here, you have to use that binomial expansion that you guys all love so much using Pascal's triangle.
Great.
But we're not going to do that. I'm going to make it easier. If it's a multiplication, it's super easy. You just distribute the c into both of these powers, and this becomes x to the power of a. Okay, it's a power to a power, so a times c.
Just to the powers, not to the...
Times y to the power of b times c.
Exactly, yeah. You kind of just distribute the power
Bang.
to both of the powers. And that's assuming that there is a multiplication. If there's a plus sign, you're kind of out of luck, and you have to do a giant binomial expansion.
Ew.
And this is almost the exact same rule, except there's a division symbol. There's a fraction. Who wants to try this one?
Ew. Do you
Evan's trying to look down at his lap as if he has a cell phone, trying to distract me. Evan, go for it.
You have a cell phone.
What is the answer here, Evan? It's x to the power of... You distribute again. So this power of c goes up here, and it goes down here. When I have a power to a
Bang,
power,
bang, bang.
what operation do I do, Evan? Do I add them? No. When I subtract them whenever I do division, but if I have a power to a power, I do
Oh.
multiplication. So this is going to be x to the power of a plus c?
Times.
A times C.
It is a times c. What about the denominator? It's going to be y to the power of what, Evan?
What?
Y to the power of?
B times C.
There it is, b times c. There's a bunch of reasons for why we do these. They follow the rules of math. If you want a concrete example on why does this work, because if you have 2 to the power of 2 times 2 to the power of 3, this is equal to 2 times 2 times 2 times 2. No, I should write 2 times 2 times 2. Again, I have 2 copies of 2. I have 3 copies of 2. I have a total of how many copies of 2? You just add them together. 1 plus 2 plus 3, or sorry, 1 plus 1 plus 1 plus 1 plus 1 adds up to 5. This is equal to 2 to the power of 5. Same thing over here. This comes from cross-canceling. A power to a power is being multiplied. There's extra copies. I can explain these further if you guys are at all curious. Let's jump into some example problems.
Oh, wait,
All
so
right.
no, guess what? I know this one.
Let's stay. Is it related to math?
No, but it's related to your class.
We'll do that question later. Eli.
Negative 42 to the x to the power of 9.
Negative 42. How did you get negative 42?
Multiplying the base.
Or multiplying these coefficients?
Multiplying the coefficient.
Negative 7 times positive 6 gave us a negative 42. Perfect. And then what did you say for the x? It was x to the power of
X to the power of 9.
9. Why is it 9 and not 20?
Because you add them.
Yeah, exactly. When I have the same base, you add
Bang,
their
bang,
powers.
bang.
That was our first rule over here. Same base, you add these powers,
What?
a plus b. Excellent job. Yeah. Let's try another one. I have a fraction. So this one, there are 2 parts to it, right? There's the first part, which is simplify this fraction, which is just the coefficients. And the second part is use the properties of exponents on things that have a same base. And this one just is the property of exponents. So first,
2 over 4.
oh, it does, yeah, exactly. So this turns into a 2 over 4.
Wait.
Wait, can we go even further?
How?
1
Oh,
over
yeah, 'cause
2.
you got the... Oh.
How did you get 2
1
over
over
4?
Wait.
It looks like he divided by 8.
No.
Divide by 8
Wait.
gets a 2. Divide by 8
Why
gets a
would
4.
you divide by 8?
What should he have divided
Oh, I
by?
forgot. You gotta divide
but
by...
why?
You gotta divide by 6.
We are
Wait,
simplifying this fraction.
You gotta divide by
The
6.
first part of
Oh, you have to
this,
simplify
the first part
it.
of this is to simplify.
Sorry.
Evan, what should this fraction really
It
be?
should be 1 over 2.
It should be 1 over 2.
Good
Yeah.
work, Evan.
Okay, so that's the first half, and then I'm going to do a multiplication symbol because technically all of those have a multiplication symbol. If you don't see any symbol in between, you assume that
Bang,
that symbol
bang.
is multiplication. Okay, x to the power of 8 over x to the power of 10. There's 2 ways of doing this problem. Who wants to try one of them?
Don't you just add them together?
Well, you don't really add them, right? Because
Oh, yes,
whenever I
I
had
subtract.
division, I subtract them. So if I subtract them, what am I going to have?
For you have 1x.
Negative 2.
X to the power of negative 2. And oh, look! Okay, so I did say in the instructions, I want only positive exponents. That's a negative exponent, so I need to have some sort of trick of getting rid of a negative and making it positive.
Flip it.
Or like, what is that?
Flip it, yeah, Eli's got it. You flip it.
Minus 10.
So, and here's the key part. And I will repeat this at least 2 more times in this class. When I have a negative power, you only flip the thing that's underneath, the base that it's referencing. I don't flip the 1/2, I only flip this x. So this x is going to go to the bottom, and I have 1 over 2 times 1 over x to the power of what?
2.
2. It's now a positive 2. It was a negative 2, but I flipped it, so it's now a positive 2. and
That's the
it's
answer.
all in one fraction. So let me simplify this a little bit further. I can say it's 1 over 2x squared. So that's one way of doing it. There's another way of doing it. That's a shortcut that I would like to show you guys.
Oh boy.
So I'm going to say that that's path 1. That's option A. You can also do path B. Here's another path. You still simplify the fraction just like Evan did. You have 1/2 here. But instead of doing top minus bottom, I can instead do
Bottom minus top.
bottom minus top. And the answer goes wherever the largest power was. The largest power is in the denominator, so the denominator is where my answer is going to go. My denominator is going to have an x, and I'm going to do bottom minus top, and I'm going to do 10 minus 8 to get a 2. What's left up here? You have to have something, so we call that a 1. Therefore, this is just going to be 1 over 2x squared. And you can see how short path B is versus path A. Path B is the shortcut because there are less steps. All right.
Okay.
Fist of 5 on example 2.
Would path A be the better option if the cove or like the power was bigger on the top?
Exactly, yeah. So did you guys all hear what Eli said?
Y'all
Let's,
should have been paying attention.
Marley, let's see if you're paying attention. What did Eli say?
That path A would be the better option if the exponent was bigger on the top.
Oh my God, great listening skills up there. Yeah, but in this
I
case,
was
the
listening to you,
numerator
Eli.
the numerator power is smaller, so you want to use that trick down here.
I'm sorry.
All right, let's go ahead and move things down just a little bit.
Oh, we did.
All right, this one is notoriously tricky. Example 3.
Boy, what's
Can I make? I'm gonna fall into the trap, so you can see how to avoid that trap. Right, Evan and Eli, who are
Trap.
definitely paying attention. Here's the trap. People will say this is 3x to the power 4, which is wrong. Why is that wrong?
Because there's no what's it called?
because there's no power?
No, good guess.
An imaginary power.
It's not
No.
wrong.
What was that, Evan?
It's not wrong.
It is wrong.
It's not though.
It is very, very
No,
wrong.
it's not.
This is a very common mistake that I see from students' work year after year, and I want no one in here to make that mistake ever again.
Oh.
Here's the correct answer. Oh, you got it?
If it's to the
Okay.
Here's the thing. There weren't one things inside the parentheses. There were two things inside the parentheses. There were two bases.
Oh, it's gotta be 12.
This is close. You're close.
No?
It's 3 to the power 4, not 3 times 4, right?
Ah.
This is invoking this rule right here. There are two bases, which means you distribute the power here and here, which means I need to have this 4 going here and here to get a 3 to the power 4 times x to the power 4. Do we know what 3 to the power 4 is from our last lessons?
81.
Very good. It is indeed an 81
Good
x to
work,
the
Eli.
power 4. What a positive atmosphere we have in this classroom. Good job, students. No. Don't ruin it.
Just kidding.
All right, let's see if you guys can use that same trick on example 4, and I added another curveball in here. So the first thing that I see is, I have a power to a power, so I'm going to distribute this power here and here. There are two bases, so both of them need to have their own power of -2 to do the distribution properly.
2 to the power negative
2 to the power of -2, x to the power of 6.
X to the power of positive 6. Exactly. But I'm not done because look at this. It told me I can only have positive exponents. That's a negative exponent, which means
You have to flip it.
flip it. And we have to be careful about that indirect object pronoun. What is it talking about? Am I talking about it? It? What is it?
2 to the -2.
This is the thing that I'm identifying. Therefore, the base that I'm going to be flipping, it is just the 2. So this is going to turn into x to the power of 6 stays on the top, but the bottom now has a 2 to the power of a positive 2. Exactly. And 2 to
Which
the power
is
of positive 2
4.
is 4. Let's simplify it Marley's way. Let's say x to the power of 6 and Marley's 4 on the bottom, and we get our final answer. All right, now it's time for some truly terrible problems where I will try to trick you as many times as possible. I'm going to give you 2 of these bad boys on the notes, and hopefully you won't make a mistake once we get to the actual homework.
There's a question like that on homework?
Oh, yes. If you look at the very bottom, the last 4 or 8-ish questions
I don't
have...
like the way that number 12 looks. The way that it,
He's looking at me
it has-
strangely.
it's 4 and then 2.
Yeah, I know.
I don't like that.
I mean, look at this one. I have a 2 and then a 3 right there. Like powers within powers, right? Let's work on example 5 first. All right. So, my first thing that I like to do is to get rid of anything that has a 0. So, I'm going to purposely make a mistake and you will tell me why I'm wrong. Here's my mistake. I will say, oh, I see a power of 0. Therefore, I cross off that. That's wrong. Quiet raised hand. Why is that wrong? Eli's been contributing so much. I need to call on someone else.
Just do me.
Eli.
You need to cross with the X.
Just the X, not the 4.
That's what I was gonna say.
You have to be careful about, give yourself a pat on the back then. You got it correct. Good job, Marley. And you're willing to contribute. So this x to the power of 0, and only the x to the power of 0 is crossed off. Don't accidentally cross off the entire 4 and x to the power of 0. However, look at this 0. I can cross off more than just the x squared. I can cross off the entire 7x squared. And someone explain why. Marley, yeah?
Because you're distributing the 0.
Yeah, it's kind of like both of them have a 0, therefore both of them go to 0. You can cross that whole thing off. Why am I normally when I do my cross canceling, I put a number. I could put a number 1, but why do I not write the 1 anymore?
Because you don't need it.
Because we are multiplying by 1. Multiplying by 1, you don't need to write multiply by 1, right? So I can go ahead and just kind of leave that off. Okay, so that's usually my first step. Find the easy things that have zeros, cross them off. And now I can start moving things around. If I see any sort of distribution that I can do, usually I want to do that next. Can someone help me with the distribution down here? What is that really going to turn into for the denominator? I haven't heard very much from Grace or Melly yet. They have contributed, but I want to hear more.
3 to the power of -2 and x to the power of 2.
X to the power of positive 2. Let's save off-task questions until after the lesson. Okay, so I have the distribution out of the way, and I'm going to, everything is being multiplied. So there wasn't originally any sort of symbol in between the 3 and the x to the power of -1, but if there is no symbol, you assume it's multiplication. And all of these are being multiplied. This one is gone. I still have a 6x to the -2. I have a 6, and I have an x to the power of -2. That's the entire denominator. I can make that look a little bit nicer. What about the numerator?
You have 6x to the power of. Why am I blanking on 3 plus 4?
It is indeed 7, yeah, because you're adding these powers. 4 plus 3 equals 7.
No way.
So you guys are allowed to do cross-canceling here. Do you guys see a same number on the top and the
Oh
bottom?
my god, yes! 6.
Yeah, let's go ahead and cross it off. Cross-cancel, and technically that cross-cancels as a 1, but I'm not writing that because we're multiplying. And now I can write this a little bit simpler. On the top up here, I have an x to the power of 7. Okay, any sort of...
You're gonna put the 3 to the power of -2 up there. Because you have to flip it.
Oh, very good. Yeah, so Marley's seeing, that has a negative, so that goes to the other side. This is going to be a 3 to the
And the x.
positive 2. Oh, she wants to move that one as well. It has a negative. Exactly. X to the power of positive 2 up there. And what's left over?
X to the power of 2.
X to the power of 2. Very nice. Oh, I see something that can cross-cancel.
X squared.
X squared. Grace and Evan got it. X squared and X squared are gone, leaving behind a... Okay, let's simplify 3 squared. Someone shout out
9.
9. Okay, so I have a 9, and I still have this x to the power of 7, so 9x to the power of 7. Very well done. And you can see this is simplified because I have only one variable. If I have 2 x's, that means I can go further, and I don't want any powers if I can avoid it. So this is much simpler than that. All right, fist of 5 on example 5, because we did a lot. I need to check in with you guys.
That was pretty easy.
Pretty easy. Oh my goodness. That was... Like, there are a ton of problems all in one, Grace, but if it's easy for
I
you...
don't like the answer for number 12 either.
Okay. Let's try example 6. Whew! This looks even more disgusting, even spicier than the last problem. All right, I'm not going to help as much as last time. Last time I told you what to do for your first step and your second step. This time, I'm going to let you guys tell me what to do. I see Eli really wants to contribute. Go for it, Eli, again.
You find all the zeros and you cross them out, so you just cross out that x.
Yeah, we only have 1. All of these others are not 0. So let's cross you out. Okay.
And then you want to distribute next?
And he wants to distribute. Where are you distributing? Are you? Because I see there's like powers up here.
Start distributing at the bottom, or should you start at the top first?
Excuse me, you just cut my...
You can start wherever you want, Grace.
Now you
when
can
you're
go.
spoken to.
Now you go. Jesus.
Eli wants to start on the bottom. I'll let him do his contribution, then we'll choose someone else.
Talk.
Eli, you said that you wanted to distribute that -3. Can you read me the new problem after you do your distribution?
That's not the -3. I was distributing.
Oh, sorry. Which, this -3 right there. Sorry. This -3, tell me what we have on the top.
Distribute that into x and to -2.
So what do we get? Tell me what to write.
You get, well, first you gotta write 6x3.
6x to the -3.
-3 times 2, -3. Times x, -3.
And what's the last part of the numerator?
Times 8.
Good. Don't forget that 8. Okay. I need another volunteer to start working on that denominator.
Nose goes.
Bruh.
I got this down.
All right, Marley.
Okay.
Didn't touch your nose. She did it on
So
purpose. She wants to contribute.
We're gonna do. Let's- You guys. So for the 3, for the first one,
Whoa. For this third, yeah.
you distribute the 3 into the 2, right?
3 into that 2 or that 2?
That 2. The second one.
So what operation? If I have a power to a power,
Multiply.
you multiply. So this is really
6.
2x to the power of 6. Okay, let's go ahead and simplify this one a little bit more.
Goodness. Why did I have to do this one?
Because you didn't touch your nose fast enough.
Don't you just do it into the 2 powers, the -2 and -1?
Yeah, exactly.
Yeah.
So wait, what is that going to be then, Grace?
Yeah, what Grace said.
-3.
Well, I'm.
What is
It's a power to a power. Power to a power doesn't mean add. It means multiply. What's a negative times a negative? So this is going to be 2 to the power of 3 times x to the power of 6 times x to the power of -18. Whew.
But
All right.
you have to simplify the 2x.
I know. That was only our first round.
Oh, I think
Now we're on the second round. Okay. Now what can we do?
simplify 2x
Yeah, you need to distribute the x.
into the x and into the 2.
All right, I'm seeing
six.
this one is going to go here and here. I hear some background talking. Let's try to stay on task, gentlemen. So that means in the denominator down here, why does it do that?
Your board's tweaking.
YouTube.
That means in the denominator down here, I have a 2 to the power of 6 and an
X to the
x to the power of 6. Is there anything else I can do to that bottom to make it a little bit easier?
Don't you have to put the
You can put x to the power of -18 on the top.
Ooh, let's do it. Yeah, so we're also going to, let's show our work. We're going to take you and move you. I don't want to cross off the 18 though. We're going to take all of that
on the top?
and move it to the top.
And then,
So
and then you have to
that's
do
gonna
all
be-
the negatives and put them on the bottom.
x to the power of 18. Okay, did we finish all the stuff down here?
Yeah.
Okay, now let's work on stuff up there.
Oh yeah.
Does the 6 move?
No.
No.
Or no.
Are you sure? It has a negative, right?
Oh, yeah, so
No, but it's it's
You're
the
wrong
x that
because
has the
that's a teacher
negative.
mistake. That's extra credit.
I don't know.
The six
Yeah,
days
log
is the
it.
experts.
And I purposely was trying to lead you astray. I'm not going to give extra credit for that one. It is a power of 1 that we didn't really see, and that's a positive. So it stays behind. There's that 6 stays behind. What does flip, though?
The x to the power of -3.
X to the power of -3 goes to the bottom. So let's go ahead and put an x to the power of +3 on the bottom. What about this 2?
It goes to the bottom.
It goes to the bottom. It has a negative power. So this 2 to the -3 goes to the bottom. And I say, wow. So 2 to the power of +3 or 2 cubed, as Grace said. And what about this x to the power of -3?
-3 goes to the bottom.
Oh my God, that goes to the bottom as well.
And the 8 stays.
So I have an x to the power of 3 and the 8 stays. So I'll put an 8 up there and whew. All right, that is no negative powers, no distribution. All I have to do is our basic properties.
Even cross can't.
Oh my God, this is going to be a lot. Okay, so the top, do we want to, so here's the trick when you have when we have numbers on the bottom and the top, you don't have to multiply these yet unless you want to. Can we just leave this as 6 times 8 for now? I would like to. 6 times 8 times x to the power of 18. That bottom though, we have a lot of x's. We have x, x, and x. Can we make those all into 1x?
Yeah.
What is that going to be? 6. Am I adding, multiplying? What operation am I doing with these powers?
Adding.
Or adding.
Adding. It's the same base and they're being multiplied. So 6 plus 3, shout out.
6 plus 6 is 12.
Oh, yeah, you did 3 and 3 to get 6, and then 6 plus that other 6 is 12. So I got x to the power of 12 as well. All right. And then what about all these 2s? 2s and 2s. This is really 2 to the power of, how many 2s do we have? We have 6 plus 3 plus 3. Isn't that 2 to the power of 12 as well?
Yeah.
Because it's the same base, same base, same base. So add, and you get 12.
You have to do multiple.
Whew. Well, that is a gigantic number.
That's 2 to the 12
There's a lot of 2's on the top as well. I'm going to go ahead and do an extra trick that I normally don't teach, but you guys are advanced enough to require this. Check this out. Did you know that 6 is the same thing as 3 times 2? Mind blown. I know. Stay with me. Did you know that 8 is the same thing as 2 to the power of 3? It is. I mean, it's a perfect cube up there. If you didn't know that, you can look at my wall. And I still have an x to the power. Oh, wait. Before I do the x's, look at what we can do here. What can we do here?
Oh, cross cancel.
Kind of, yeah.
Or cross out.
What is it? Is the answer going to be on the top or the bottom when it's done with positive exponents?
Top.
Top, because the top has a bigger. So let's do the top minus the bottom.
18 minus 12.
18 minus 12.
6.
6. Okay, now we have to worry about this 2 to the power of 12 on the bottom. 2 to the power of 12 on the bottom. But watch up here. This is 2 to the power of 0. What power do I have up here? 1. If there's a hidden power, you assume that power is 1. And I can do what with these powers? Add them. So this is really 2 to the power of 4 on the top. So I really have, let's come down here. This is really equal to 3 times 2 to the power of 4 all over 2 to the power of 12. And then I still have that x to the power of 6 on the top. What do you notice about these?
You can cross them out.
Kind of.
The bottom is
Or,
going to be
yeah.
Bottom's gonna be 8.
Bottom is going to be 2 to the power of 8. Why did you do 2 to the power of 8?
It's gonna subtract.
Subtract
Bigger
it.
numbers.
Yeah, so I have 3x to the power of 6 over 2 to the power of 8. And then
That's
we have
a
to do
3.
2.
You wrote a 3 and not a 6.
That is a...
Is that a teacher?
I'll give it to you. Yeah, log that credit on that.
Go!
So from here,
Give me that.
I need to figure out what 2 to the power of 8 is, and I'm essentially done. So 2 to the power of 8 is 2 times 2 times
What's the
2 times 2. Today's date is the 24th of February.
So 2
Times
20.
1, 2, 3, 4. Wow, there's a lot of 2's. Let's move you over here.
Multiply 63.
Well, 2 times 2 is 4, and 4, and 4,
God.
and 4. 4 times 4 is 16. 4 times 4 is 16, and 16 squared!
Is 256.
Oh my God, Brainiac over here. 256. She just knew that off the top of their head. 256. Whoa, over here.
Totally didn't just do the math.
Is equal
With
to
my finger
3x to the power of 6 all over 256 for our final answer and box it. What a problem. Fist of 5 on example 6. How do we do?
I mean, it's
I'm seeing a 5, a 4,
I don't understand
a
the
3.5.
end. I'm a little.
You don't understand the end. We're from here to here?
No, from.
no like
From here to here?
No.
like all the 2's.
From here to here?
Yeah.
Okay, so
Or more like from
Isn't that a Ukraine knuckle
here to
sandwich?
here. Because, like, do we have to do that?
we don't have to do that. What we could have done is we could have got 6 times 8, which is 48. Let me do another path. You could have done 6 times 8 on the top to get 48. And on the bottom, you would have done 2 to the power of 12, which is 4,096.
you put 2 to the power of 2.
And then you would have to reduce these by constantly dividing and dividing. What you could divide the top and bottom by is 16 divided by 16, and you'd get 3 over 256.
Oh, okay.
And then you just have
You could have done it that way.
But then how would have you got the x? You would have got the.
And then you would have to do the x's by themselves. So this x to the power of 18 over x to the power of 12. I don't think anyone got confused to get x to the power of 6. And that stays x6, so that doesn't
And then you
change.
just carry it.
Oh, okay.
It was these numbers that really got to us. So I was trying to do a trick there. You don't have to do that trick. You can do it this old-fashioned way.
Okay.
And pro tip, if calculators are enabled, you can use a Desmos scientific calculator. If you punch in 48 over 4,096, it will reduce the fraction for you. Cool. Any other questions on this lesson before we jump into the homework? Oh, we do have a challenge today, too.
No challenge.
Yes, we do. But I'm going to go ahead and end the lesson right there.
I'm not doing no challenge, boy.
I got the
Mr. Sindel, you made a mistake on number 5.
That video's
What's the mistake I made on number 5, Melly?
You didn't multiply by 4.
Oh, I didn't multiply by 4. We crossed off the 0 over here, but I needed to multiply by the 4. Here, let me add that in really quick. Let me sign your extra credit tracker in a sec. That needs to be multiplied by 4, and that means our final answer needs to be multiplied by 4 as well. This 9 is a 36. Good catch, Melly. All right.